Technology Risk Part 8. This episode has 20 questions. For each question, take a moment to think through your own answer before I share a strong approach. Question 1. GCP DevOps risk. What risks exist when using service accounts? Here's a strong way to approach it. Risks include overprivilege, key leakage, unclear ownership, cross-project access, long-lived credentials, privilege escalation, and insufficient logging. I reduce these risks with least privilege, no user-managed keys where possible, workload identity, service account impersonation, key rotation, owner labels, audit logs, and access reviews. Nice. Let's continue. Question 2. GCP DevOps risk. How would you implement least privilege across GCP projects? Here's a strong way to approach it. I would inventory IAM bindings, map roles to actual usage, remove direct user grants, use groups, replace basic roles with predefined or custom roles, apply IAM conditions, create environment-specific access, monitor policy changes, and run periodic reviews. I would prioritize production, customer data, and privileged roles first. Great. Moving on. Question 3. GCP DevOps risk. How do you monitor cloud security and compliance? Here's a strong way to approach it. I use Security Command Center, Cloud Asset Inventory, audit logs, IAM analysis, vulnerability scanning, org policy reports, SIM integration, IAC scanning, and custom dashboards. Findings should create tickets with ownership and SLA, and trends should be reported through CREs such as public exposure, overdue vulnerabilities, and privileged access exceptions. Alright, next question. Question 4. GCP DevOps risk. How would you perform a risk assessment before deploying a new Kubernetes cluster? Here's a strong way to approach it. I would review cluster purpose, data sensitivity, network design, control plane access, node security, RBAC, workload identity, secrets, admission policies, logging, monitoring, backup, upgrade process, multi-tenancy, CI or CD deployment flow, and incident response. I would document risks, required controls, owners, and go-live conditions. Let's keep going. Question 5. GCP DevOps risk. How do you ensure infrastructure as code changes are compliant before deployment? Here's a strong way to approach it. I use pull request review, Terraform FMT or validate, plan review, IAC security scanning, policy as code with OPA or Sentinel, required labels, approved modules, least privilege CI or CD identities, and environment approvals. I also capture evidence from pipeline runs so compliance is built into the workflow. On to the next one. Question 6. GCP DevOps risk. Describe a cloud security incident you investigated and the lessons learned. Here's a strong way to approach it. Use a truthful star example. A strong template is: a misconfiguration exposed a cloud resource. I helped contain access, reviewed logs, rotated credentials if needed, assessed data exposure, communicated impact, and created remediation. The lessons were to add preventive policy checks, better monitoring, clearer ownership, and faster incident playbooks. Good. Here's another one. Question 7. Network Hub Scope. What is a network hub and spoke architecture, and why do organizations use it in GCP? Here's a strong way to approach it. A hub and spoke architecture uses a central hub network or project to provide shared connectivity, security, DNS, inspection, and access to multiple spoke projects or VPCs. Organizations use it to standardize network controls, reduce duplicated connectivity, centralize governance, and make routing, firewalling, hybrid connectivity, and monitoring easier to manage at scale. Nice. Let's continue. Question 8. Network Hub Scope. What should be included in the scope of a network hub project? Here's a strong way to approach it. A network hub project usually includes shared VPC host networking, interconnect or VPN termination, cloud router, cloud NAT or egress controls, firewall policy, DNS forwarding or peering, private access to shared services, logging, monitoring, and connectivity to security inspection tools. It should not become an uncontrolled dumping ground for application workloads. Ownership boundaries must be clear. Great. Moving on. Question 9. Network hub scope. How would you design shared VPC with host and service projects for a hub and spoke model? Here's a strong way to approach it. I would place shared network resources in a host project and attach service projects for application teams. Network admins own VPCs, subnets, routes, firewall baselines, NAT, DNS, and connectivity, while application teams deploy workloads in service projects with limited permissions. I would separate environments, use IAM groups, enforce org policies, label resources, and document subnet ownership and change workflows. Alright, next question. Question 10. Network hub scope. How does Network Connectivity Center help in a hub and spoke network design? Here's a strong way to approach it. Network Connectivity Center provides a managed way to connect and manage network spokes through a central hub for hybrid and cloud connectivity use cases. It helps simplify connectivity between VPCs, on-premises, and branch networks, and gives centralized visibility. From a risk perspective, I would still review route propagation, segmentation, firewall policy, ownership, and whether the design creates unintended reachability. Let's keep going. Question 11. Network hub scope. What are the routing risks in a hub and spoke architecture? Here's a strong way to approach it. Routing risks include unintended transitive access, overlapping CIDR ranges, route leaks, asymmetric routing, incorrect route priority, black hole traffic, overly broad dynamic route propagation, and unclear ownership of route changes. I would control these with IP planning, route review, cloud router governance, change approvals, route monitoring, and clear documentation of allowed paths. On to the next one. Question 12. Network hub scope. How would you manage firewall rules centrally while still allowing application team ownership? Here's a strong way to approach it. I would define centralized baseline firewall policies for high-risk controls, such as denying public admin ports and allowing only approved shared services. Application teams can request or manage app-specific rules within guardrails using tags, service accounts, approved modules, and review workflows. Logging, expiration dates, owner labels, and periodic cleanup are important to prevent rule sprawl. Good. Here's another one. Question 13. Network hub scope. How would you design DNS resolution across hub, spoke, on-premises, and private GCP services? Here's a strong way to approach it. I would define a DNS architecture with cloud DNS private zones, DNS peering or forwarding, inbound and outbound forwarding policies, and clear ownership of zones. I would ensure on-premises and GCP name resolution works consistently, avoid conflicting zones, protect sensitive records, log DNS queries where needed, and test failover and split horizon behavior. Nice. Let's continue. Question 14. Network hub scope. What are the security risks of VPC peering, and what limitations should you consider? Here's a strong way to approach it. VPC peering can create broad private connectivity if routes and firewall rules are not controlled. Risks include unintended access between environments, overlapping IP ranges, unclear ownership, and weak monitoring. Important limitations include non-transitive peering and route exchange constraints. For large environments, shared VPC, network connectivity center, or a more deliberate hub design may be safer than many ad hoc pairings. Great. Moving on. Question 15. Network hub scope. How would you design outbound internet access through cloud NAT or centralized egress controls? Here's a strong way to approach it. I would avoid giving workloads unnecessary public IPs and route outbound traffic through cloud NAT or centralized egress controls. For sensitive environments, I would use egress allow lists, proxy or inspection layers, logging, DNS controls, and workload identity-based access where possible. I would also monitor unusual destinations, high egress volume, and changes to NAT or route configuration. Alright, next question. Question 16. Network hub scope. How do you segment production, non-production, shared services, and third-party connectivity in a hub network? Here's a strong way to approach it. I would segment by environment, trust level, data sensitivity, and ownership. Production and non-production should have separate projects, subnets, firewall policies, and access paths. Shared services should expose only required ports, and third-party connectivity should be isolated with strict routing, firewalling, logging, and contractual controls. Segmentation should be tested, not just documented. Let's keep going. Question 17. Network hub scope. What monitoring, logging, and crease would you define for network hub risk? Here's a strong way to approach it. I would enable VPC flow logs, firewall logs, cloud router logs, DNS logs where appropriate, VPN or interconnect metrics, NAT metrics, and alerts for root, firewall, DNS, and connectivity changes. Crease could include open admin ports, public IP usage, firewall rules without owners, route changes, VPN tunnel instability, DNS failures, overlapping CIDRs, and unauthorized connectivity exceptions. On to the next one. Question 18. Network hub scope. How would you perform a risk assessment before onboarding a new spoke project or VPC into the hub? Here's a strong way to approach it. I would review business purpose, data sensitivity, environment, CIDR ranges, routing needs, DNS needs, firewall requirements, IAM ownership, logging, internet egress, third-party dependencies, and compliance requirements. I would check for overlapping IPs, unintended access to other spokes, required controls, evidence of approvals, and rollback plans before connecting the spoke to the hub. Good. Here's another one. Question 19. GCP landing zone. What is a GCP landing zone, and why is it important for enterprise cloud adoption? Here's a strong way to approach it. A GCP landing zone is a pre-designed cloud foundation that defines organization structure, projects, networking, identity, security controls, logging, billing, and governance. It is important because it gives teams a secure and repeatable way to build in the cloud while reducing misconfiguration, inconsistent IAM, audit gaps, and uncontrolled cost. Nice. Let's continue. Question 20. GCP landing zone. What core components would you include in a secure GCP landing zone? Here's a strong way to approach it. I would include organization and folder hierarchy, project factory, shared VPC, hub networking, IAM groups and roles, org policies, centralized logging, security command center, KMS, secret manager, billing and budgets, labels, monitoring, CI or CD or Terraform modules, policy as code, audit evidence, and documented onboarding and exception workflows. Great. Moving on. That wraps up this episode. Nice work practicing, and see you in the next one.